I'm here today to talk to you about Trino. Uh, as introed, I am a developer advocate here at Starburst. I also handle Trino release management. I'm based out of San Diego. I love it here, and I'm also excited to talk to everyone here about Trino. It's a great project, and spreading awareness and letting you know what you can do with it is super fascinating. There's always something that someone doesn't know, whether you're entirely new and have never heard of it before, or you're a seasoned Trino veteran using it every day. There should be some information in this talk that you find useful. But we'll get started, I think, with a little overview of what Trino is for the people who may not be familiar with it. Um, so this is our big word soup definition of what Trino is. Uh, Reading it verbatim, Trino is a ludicrously fast, open source, distributed, massively parallel processing SQL query engine designed to query large data sets from many disparate data sources. Open source, of course, a key thing for being here. It is the Apache license, though not an Apache project. So you can use it however you see fit, though it is not under the Apache Software Foundation. It is open as open can be. Now, with the rest of this word soup, the keywords in the middle there that I've highlighted are SQL query engine. That's ultimately what Trino is at the end of the day. And what it does is it allows you to run SQL queries on a wide variety of data sources with standard ANSI SQL. So if you know SQL, you can use Trino, and it leverages that SQL to connect to data and query it in place. Trino does not store database or not store data. It is not a database. It is a query engine. So you run SQL queries, it executes that on data wherever it already exists. And it goes at scale and it goes fast. So if you have lots of data and you want to query it, you know SQL, Trino is a great place to look. So one of the questions, we're using this word many here, is how many data sources is many data sources? And the answer is that as I was slotting all of the logos into this slide, I ran out of room and had to put the bottom of the alphabet in the top right corner. So Trino is designed to basically connect to anything that stores a lot of data. There are additional connectors coming that we'll talk about a little later, but this is just a brief overview of everything that exists. So one of Trino's key use cases is query federation. If your data is a bit of a mess, whether due to acquisitions or mergers, or the fact that you just couldn't make up your mind and decide where you wanted all of your data to live, Trino can connect to that data and query it all at once. You can join data across these different data sources and get that data in one query result. So whether it's in 4 places or 8 places or one place, one SQL query can access all of that and return you results in a single query output that you can then export however you see fit. The other key Trino use case is that it's particularly good at querying the data lakehouses. So Hive, Hudi, Delta Lake, and Iceberg are where Trino truly shines and works at massive scale. So if you're considering moving to a lakehouse or you have a lakehouse, Trino is one of the best ways to query those. And that is one of the key use cases we see in the community is having that data in a lakehouse and then wanting Trino to access that data. So that's the data sources, but Trino also has a ton of clients. So whatever you're used to using for data visualization, for accessing that data, for writing your queries, modifying your queries, you can do that with whatever client you want. A large number of clients have support for Trino. This is actually not even all of them. I once again ran out of room on the slide and then some. So I had to be a little picky. But one of the other things worth mentioning is that kind of one of the key tenets of Trino is that it just uses SQL. So if you know SQL, you can know how to use Trino. But what we've seen this year in particular is clients that are in the Python ecosystem adopting Trino and translating Python code into Trino SQL. So Fugue and Ibis are 2 such examples where if you haven't developed those SQL skills and that's not where you're strongest and you're better at analyzing and writing and wrangling your data in Python, you can use these tools in the Python ecosystem and they can literally translate that Python code into Trino SQL for you. So you don't need to learn a lick of SQL. You can just write your code in Python. And that can kind of help you get the best of both worlds where you're able to leverage those Python skills. But if you're trying to query large amounts of data at scale where Python may have some performance issues, you can then use these tools, connect to Trino, and get that Java-based SQL query engine speed that can handle terabytes, petabytes, exabytes of data, despite you writing Python code on the front end of that. So that's a really great way to get all that you want in the world by leveraging some of Trino's clients. So it's accessible with a lot of things. It can query a lot of data. Um, so that's kind of where Trino exists. But how did we get here? Um, where did Trino come from? So it was created in Facebook in 2012. The key problem that Facebook was facing was that they had Hadoop and Hive, but these tools were designed for throughput to handle data at Facebook scale, but they were not designed for latency. So if you were a data scientist or an analyst or an engineer and you wanted to go look at some data, you could write your query, set it to run, and it could take 4 hours or 6 hours or 12 hours or 18 hours, which is a really long time to wait for some results. And particularly if you're like me, and when you go to write a SQL query, you inevitably bungle something and mess it up and need to rewrite it and run it again. Waiting 18 hours to get told you messed this query up is a major inconvenience, and it delays your insights by multiple workdays, which can be prohibitive to understanding what's going on and addressing problems. So Facebook needed faster turnaround times for ad hoc queries and analysts. And at the time, they hired some engineers to create a new open source engine called Presto to help take those query times down from hours to seconds or minutes. So, as I've mentioned, one of the key ideas was that their analysts and data scientists already knew SQL. They were already writing SQL queries all of the time. So, from the beginning, Presto was intended to leverage this SQL interface and not require these analyst, data scientists, engineers to learn new skills. It was SQL from the beginning because everyone already knew SQL. SQL is here to stay. It's not going anywhere anytime soon. And Trino has hooked into that. So in 2019, the creators actually left Facebook to double down on the open source community and make sure that the project had this community focus, and they forked the project. So for a year, there were two different Prestos that existed. There was Presto DB and Presto SQL. And Presto SQL was the fork created by those original creators. There's a lot that went into that decision to leave and fork. There's a great blog on the Trino website if you're curious and want to get into the drama. That could be an entire talk or two on its own, so I don't have time to do that today. But about a year later, Presto SQL rebranded to Trino. So if you're familiar with Presto but haven't heard of Trino, Trino is just Presto but new. It's a different fork. Development on the Trino fork versus the Presto fork has been about 3 times more. So it's a little faster, more feature rich, and has been going at a quicker pace over the last 3 years as it sees more community adoption, whereas Presto has more or less been focused on the Facebook use case. Massive adoption has continued since then. So the co-founders ended up at Starburst, which is the company I'm at as well, to continue that development. And development since then has reached new heights. So for the rest of the talk today, let's talk about what those new heights are, what's been going on in Trino. If you've been checked out or you haven't been paying close attention, you may have missed out on some really awesome features and things that we've done this year. So I'm here to give you a project update as to what's gone on in the world of Trino. So to start with, here's some key features you may not know about that weren't this year, but have been relatively recent. Table functions are one of the cooler ones. And actually, polymorphic table functions are what make them particularly exciting. The polymorphism is the fact the schema of the table returned by the function is determined at runtime rather than upfront. So I have this example function here called exclude columns that exists in Trino, where say you have a table with 500 columns and you want to run a query that excludes 3 or 4 of them, whether for privacy reasons or security reasons, or because they just have really long string text that takes up a ton of space in your viewer. I don't know what. If you don't like those columns, instead of having to write a query that lists out the other 497 columns, you can run exclude columns, list the 3 you don't want, and get the table with those 497 columns without any issue. There's more table functions based on connectors. There's a specific table function in most Java-based connectors that allows you to execute arbitrary SQL at the connector level. So if, say, you have data in Oracle and you want to use something native to Oracle that doesn't exist in Trino, you're able to pass that as a string into a table function and then run that on the underlying connector and execute that natively. That can also be used for performance gains in specific times if you know what you're doing. A second big thing in Trino that is still picking up in adoption is this thing called fault-tolerant execution. Trino has been a pretty good batch ETL, ELT engine for some time, but not the best. There's been concerns that it's not quite as resilient, and for particularly large workloads, it has had a tendency to potentially error out after nearly getting all of the way there. So fault-tolerant execution is the solution to that. It's a cluster level configuration change that enables task level retries, which is a relatively fine grain layer to retry in Trino. You can go look at the architecture if you're curious about what a task is. But the idea is that these long running batch queries are going to be much more resilient than they were before. And where historically members in the Trino community may use Trino for analytics, but Spark for these larger batch workloads and just taking on that performance hit, if you have a Trino cluster with fault tolerant execution enabled, that's no longer necessary. You can use Trino for both, and one cluster can be managed for those quick queries. And with fault tolerant execution, you can have another cluster that handles batch workloads just as well with the exact same SQL. And then you don't need to grapple between different SQL dialects and certain queries working on some systems and not working on others. A third key thing that has been improving in Trino are table procedures. These are mostly built around those lakehouse storage systems that I was talking about. And they can do a lot of cool things. The example I've got here is a table procedure that allows you to migrate a Hive table into Iceberg using Trino. It layers the Iceberg metadata on top of an existing Hive table as long as the data format is supported. And you can move from Hive to Iceberg and get that new modern data lake speed with minimal hassle and overhead, which is super handy for people who are considering about running that migration but don't want to worry about the headache of it. You can just run it with Trino and it'll work great. And in fact, if you enable fault tolerant execution, it'll work 100% of the time. So table procedures are cool. You can check the Trino documentation to see more of those. There's connector specific, and there's a lot more of them that I can't get into today. So new in 2023, those were things that have already existed, but these are things that have happened this year. So this is a project update and things that you may have missed out if you weren't paying close attention to the Trino release notes. So the biggest one, which we're all very excited about, is SQL routines. This is the ANSI SQL way to implement user-defined functions. SQL routines can be dynamically defined with the SQL language, and soon they will also be able to be dynamically defined with other languages. So if you want to run a function that doesn't exist in Trino and you want to define it in a lightweight way with SQL, you can do that now, and it works just like a user-defined function in any other system. There is a way to inline the SQL routines. So this is an example for a function called dots, where you're defining with function dots with an input of a varchar that returns a varchar. And if your input is greater than 15 characters, what we're doing is truncating it and appending a dot, dot, dot to the end. Otherwise, if it's less than 15 characters or equal to 15 characters, it does not get truncated and is just returned normally. So when we select dots, a long string that will be shortened with this inline routine, we get a long strid dot, dot, dot. When we just call a short string, we end up returning a short string. It doesn't need to be truncated. So this is a pretty simple example of a SQL routine. We have a contest for submitting more sophisticated, useful SQL routines on the Trino website. So if you have ideas for how to define functions in SQL and you want to compete in that contest, you can do so. But this is inline. So this is part of your query. You can do this. But we also have catalog level routines. So if you create a function and you declare it and you end that query, this function then exists in the catalog for you and any other users querying that catalog to use in later queries. So you can run select dots multiple times and it'll work just fine. And you can view catalog routines and user-defined functions by calling show functions from your catalog. And if a function is no good or you no longer want it, you can also drop that function from your catalog and it will no longer exist. So user-defined functions are live. Support for them is growing. We're still working on them. They're a relatively new feature, but it's a very powerful way to get the most out of your SQL queries and something that we've wanted to add to Trino for a long time. It was mentioned during my intro that I was an intern on Presto back in 2017. I laid the groundwork for this in my little intern project. Most of that code is dead, but a little bit has survived. And 6 years later, we have exactly what we wanted in user-defined functions. So it's exciting to see finally in Trino this year. Also new in 2023 is dynamic catalogs. This is an experimental feature. It has some caveats and issues with it that may warrant some caution in using it in important production use cases. I believe security is not necessarily guaranteed with these, which can be a pretty big deal if security is something you care about, and everyone cares about security. But we're working on it, and there will be more robust support for them coming very soon. The idea behind dynamic catalogs is that historically, if you wanted to add or remove a data source from Trino, you've had to shut your Trino cluster down, modify your configuration, add the new catalog to the configuration, and then boot it back up again. For large Trino clusters that are being used by users 24/7, that is a very big hassle, and it has made adding and removing catalogs from Trino expensive, and it incurs downtime or requires a very careful juggling. Whereas now you can simply create a catalog or drop a catalog as you see fit. Both are safe. So if you're going to drop a catalog and queries are currently querying that catalog, what it will do is it will block new queries from accessing that catalog. And once all currently running queries that were trying to access the data in that catalog are done, it will then remove the catalog from Trino on the fly, and you do not need to shut down Trino anymore. So that's going to make it a lot easier to use when you're creating new catalogs or new data sources or new tables. You can go ahead and add and remove them without any issue while Trino is running. Stay tuned to the release notes for expansion on this feature, so that it actually becomes completely production ready rather than just experimental. Also new in 2023, and this is pretty exciting, is the Trino Gateway. This is something that has existed in kind of a scattered, self-maintained, haphazard way for a while, but it is now officially released as a Trino-supported official project. And what it does is it is a proxy and a routing server for multiple Trino clusters. So if you are in a organization where one Trino cluster is not enough, or you want to have multiple clusters, such as for having one for ETL and one for ad hoc analytics, you've needed to separately connect to those clusters and manually routed yourself to those clusters if you've wanted to query them. With the Trino Gateway, you can go through the gateway as this proxy that connects to all of your Trino clusters and handles load balancing between them. So it also solves a historic problem with Trino, which is that Trino is pretty resource intensive. It will, for any given query, use just about all of the memory you give it. So if someone runs a really large query that's going to get, millions or billions of rows, and you just want to run a query to analyze some small 15-row bit of data, if that query is already running, you can get bullied out and end up in a queue or have a really long running query time because the cluster is so burdened with that larger query. And now, if you have multiple clusters and load balancing enabled with the Trino Gateway, the big queries can go to certain clusters and the lightweight queries can go to others. And it'll make sure that these lightweight, quick, easy queries that your users are submitting run as quickly as they should and get that attention they deserve for being these low latency, fast queries. So noisy neighbors become less of a problem when you have multiple clusters and load balancing on top of it. The other great thing that this does is it enables blue-green deployments. So if you have a Trino cluster and you want to update your Trino version to take advantage of all of the cool features that we've added this year, you can do that by creating a second cluster, shifting your traffic over to it with the load balancer, and then shutting down your old cluster to update that one as well. So now there is a way to do zero downtime upgrades from Trino version to Trino version, which is super handy because Trino is being updated all of the time. There's always new features, performance improvements being added, and it's worthwhile. And this makes it much less costly to keep working on Trino and support it for your team. And of course, one of the biggest things about Trino is that in every single release, there are always performance improvements. This year, we had a project called Project Hummingbird, the main idea of which was to do as many small performance improvements as possible. Look at the code, find any little tidbit where you think you might be able to squeeze out performance and get that performance gain to make the engine run faster. This has been the motto for Trino from the very beginning. Over the course of its life, it has always been about finding these small performance improvements and putting them into place, making sure that there is no performance loss anywhere. So this is a list. You're not supposed to read every single performance improvement. It's just meant to show off that there's been a lot. And in fact, this is just a list compiled from the first half of the year. We haven't yet compiled all of the performance improvements from the second half of the year. So this is only half of them, and this is only to the core engine. The underlying connectors have more as well. So depending on what connector you're using and what data sources you have, access to those will have gone much better as well. So Trino is always getting faster. In every release, there are always ways to speed it up, whether it's 1% or 2% or 5%, it is moving quicker. So That's everything that has happened in Trino this year. But I'm also here to discuss a few of the things coming soon. So continued work on Project Hummingbird, all of those incremental performance improvements. We have plans to keep that up. We want Trino to be as fast as possible, and that means more performance improvements all of the time. There's a Snowflake connector that's been in the works for a while. So if you have data in Snowflake and you want to query it with Trino, or expecting that to land sometime soon, and then you'll be able to use open source Trino to access your data stuck within Snowflake, which is pretty handy for a lot of people. Aluxio, which is an object storage caching company, are adding a caching layer to Trino that'll be completely free and part of Trino out of the gate, which should be a massive performance improvement for queries and clusters that are able to leverage that caching as effectively as possible and really step Trino's game up to being much better, especially when running smaller or more lightweight queries. Um, we're expecting refinements on SQL routines, those UDFs that I was talking about. Of course, improvements on dynamic catalogs and the bold and other features we have here of things that are in the works but which aren't quite ready to be announced. There's always more coming. So we're excited about that once they're closer down the line. And then we also have a testing refactor and CI improvements plan. So if you were ever thinking about contributing to Trino and you were scared by the massive testing infrastructure or how the CI works, that'll be better, and contributing to Trino will be easier, faster, and more smooth than ever. So if you think you have something that you want to contribute, take a look. Consider contributing it. We're open source, so you can do that whenever. A few other Trino numbers to talk about. So in 2023, we've had 29 releases. They're a little more frequent than bi-weekly. We generally goal on going weekly, but sometimes a week is quiet or there's a release blocker that delays things. So we're at 29 and probably will end up around 31 or 32 on the year by the time the December rounds out. We had over 5,000 commits in Trino, and that's compared to 35,000 commits total. So we've had about 1/7 of the project's activity this year, which is a lot considering the project has existed for 11 years. The update to Java 21 is in progress. Trino is modern, and that should be finalized within a couple weeks. We're already using Java 21 in some places. It's going to be required in another version or two, which should allow us to write the code in the engine better than ever. Java later versions have some pretty impressive improvements that should make it a better project to contribute to and should make it easier for code to be clean, easier, and performant. And of course, the Trino community is active and growing. We're at over 11,000 Slack members. We had nearly 700 contributors on the open source project this year. And you're welcome to come join us. I've put a link to the Slack that's hopefully short enough that you can type it into your browser, even though you cannot click on it.